Good morning, everyone. I will be beginning here very shortly. I'm waiting for some more people to trickle in, so stand by. All right, good morning, everyone. Thanks for attending. All right, so I'll go ahead and begin. Hello, welcome to the system design training for AutoVu. This system will be about 2 hours long, intended for any type of audience. Whether you're a seasoned AutoVu installer or new to the AutoVu product line, we're sure that you'll find something in this presentation for you. My name is Aaron Winkin. I'm the AutoVu product sales engineer for North America. Today with me is Howard, our Northeast Region Channel Sales Engineer. He'll be manning the chat for any of your questions. Howard and myself accumulate more than 10 years of Genetech experience and almost 20 years of LPR experience. Hey Howard, how are you doing today?
Doing okay, Aaron. Thanks for asking.
Awesome. We'd like to thank you all for attending. It's a pleasure for us to be here with you. Hopefully we'll make it worth your while. We do have a few ground rules for today. As you probably noticed, everyone attending the presentation will be muted. However, you will have the opportunity to ask any questions through the questions box found in the GoToWebinar control panel. Please feel free to ask any questions during the presentation. Howard will be responding, and if we have some additional time at the end of the session, we can definitely address any of those questions as a whole group. Security Center blends IP video surveillance, access control, and license plate recognition systems within one intuitive solution. It connects a multitude of sensors, devices, and other business and security systems to present a complete security picture for your personnel. Security Center is a modular security solution with core capabilities that can be enhanced with Genetec modules and partner integrations or add-ons. As you can see here, we have the core in the center, and then outside of that, we have the first ring, which is the optional Genetec modules. You have a few topics here. We have the SIP communications management, which is Sepelia, mobile apps and web clients, dynamic maps, which is plan manager, and we also have intrusion, which is our core intrusion role. We have a growing system of partner integrations or add-ons that provide flexibility to our customers, and that brings us to our final outside ring there, our partner add-ons. With this, you have several topics. We have visualization, video walls, dashboards, AutoCAD, identification, face recognition, biometrics, ID scanner, so on. Protection, analytics, base intrusion detection, perimeter protection, gunshot detection, asset management, etc. And efficiency, building automations, parking systems, destination managements, and so on. I wanted to give a brief overview of today's agenda. As shown below, we will go over some of the questions, the how are flags in chat that we can go over at the very end of our conversations here. Okay, introductions. As you can see, there are different roles that operate different facets of Genetec Security Center. This is just a small sampling of some of the roles, and these roles are what relates directly with AutoVu. You have the LPR manager role in charge of, among other things, keeping in touch of with the SharpV cameras and the SharpX cameras, and orchestrating where the reads and hits goes, matching its hot list for the fixed cameras and maintaining the hot list and permit list for patroller and fixed. Next to that, you have the archiver role. This role is mainly to handle the video side of Genetec. However, it plays a crucial role in AutoVu, and that is to store the images from the reads. The next role on the bottom left there is the access manager role, responsible for the AutoVu standpoint, handling the camera when it's enrolled as license plate or credential. And finally, who can forget the plugin role there on the bottom right. This role is taking care of some of the plugins within AutoVu, including the stakeout plugin, FreeFlow. Yes, I know that the FreeFlow is part of the base system, but there are some plugins related directly with FreeFlow that we can go over here soon. Some stuff that's not shown here is, for instance, like the pay-by-plate plugin as well. This brings us to our fixed LPR, the SharpV camera. There are many different applications that you can use a fixed LPR. For some of the examples shown here, it can include casinos as part of citywide surveillance, access control to secure employee parking lots, utility, law enforcement. The list does continue on with some very imaginative uses. The SharpV itself came out a few years ago, but it's already grown by leaps and bounds since its debut. With the inclusion of machine learning, the camera is able to perform some interesting things as well. Some of the features of the SharpV include higher resolution, more processing power from its previous generation. We try to make it into a future-proof design. Everything is updated via a software update. Everything inside of it, we have embedded storage, means the camera can store around 20,000 reads offline should it lose connectivity with the server. Easy deployment, it comes with mounting, nothing more really to purchase outside of a PoE plus source or anything custom. Just a bit more information regarding the SharpV. The SharpV includes dual lenses that allow the capture of the target and its plate at the same time. The overview being in color and the license plate camera being in black and white. The camera's illuminators are used to blast the plate with IR so that it stands out against the background. And the lenses are varifocal, so they're able to be used in a variety of different scenarios. As you can see here, there's also an RJ45 port. This is to provide the connectivity along with the PoE plus power. The SharpV camera is able to do some fun things on the edge, like within a future SharpV update, there's a vehicle color and vehicle type. Outside of this, the SharpV is able to do some vehicle speed estimation, also the vehicle direction of travel. This complements the FreeFlow application, being able to determine if a vehicle is either entering or leaving a parking area. Virtual loop that uses the SharpV context camera to allow the detection of the vehicle in the event that the said vehicle does not have a plate or can't be read for one reason or another, thus generating a no plate read. All the camera analytics can be used and filtered against the security center when running searches against any reads or hits also. little bit more information about the vehicle type analytic. As you see on the right-hand side there, we do categorize vehicles in different classifications. In this case, passenger vehicle, work van, pickup, bus, truck, and motorcycle. And also we have the color analytic as well. Flex Reader. This allows for some lower cost solutions that by doing the processing on the server side. So let's see how that works. Using AutoVu, there's a main differentiator. What are you doing with the ALPR data? Do you just want to get the license plate numbers or have actionable information based on that information and run it against a unified platform? Trigger events to actions tied to video, export graphical reports. That type of depth isn't something that our competitors can boast. Using FlexReader, you can use existing off-the-shelf cameras that may have been used for license plate capture or video cameras into Security Center as video source. Easily extend your ALPR coverage to non-mission critical areas. And take advantage of vehicle data to see who's coming and going when people are in your lots in order to better plan for maintenance activities and understand customer employee behavior. FlexReader is available as a perpetual or subscription license, but not on a hybrid. It can be used with any suitable IP camera on the Security Center supported device lists. Camera selection guidance can be offered, but we do not provide recommendations on specific brands for various reasons. The FlexReader plugin can run on a dedicated device or on Security Center server. However, it is demanding, so we do definitely recommend a dedicated server in this instance. Scalability figures are available for Genetec's StreamVault line. Please refer to the documentation in GTAP for more information on that. FlexReader is designed to take advantage of existing video surveillance cameras to read license plates in low speed and non-mission critical applications, as we said earlier. So as an example, from this read report within the Genetec security desk, you can see that on the left-hand side there is a FlexReader read, and the right is from a SharpV read. Notice that the context camera from the FlexReader is actually in black and white. The FlexReader's algorithm will automatically apply black and white filter to the read for the context image in this case. So even if you do stream in color, it will move it over to black and white. From a point of when to position the FlexReader versus a SharpV, here are some notes. For instance, the SharpV read speed is higher than that of the FlexReader. In a nutshell, SharpV does offer often superior results when it comes to reads, as it is a dedicated platform for just doing that. Using FlexReader, it is used in an application require a lightweight type of an approach. As you see, FlexReader is really designed for low speed, less than about 50 miles an hour. Data collection, for best position when sampling of vehicles is sought for deployments where exceptionally high capture and read rates are required. The SharpV should really be positioned. IP cameras used for reading plates will work best when the field of view is focused on the path of the license plate, so maybe not ideal for overview video of a vehicle. A separate camera will most likely be required, or a SharpV to provide both the ALPR and the color context from a single device. The FlexReader license can now be included in demo licenses, as it was before earlier. We do highly recommend that any potential customers try the plugin for their particular application before purchasing, mainly to ensure the plugin provides accuracy that they're seeking for their particular application. Mobile LPR. We're very excited to announce the new generation of this equipment. Here, I'll show you. The Sharp Z3. It replaces our former generation of the mobile equipment, the Sharp X and the Sharp XS. It is smaller, slicker, and much, much more powerful. So what makes the Sharp Z3 stand out? Well, it's new technology, such as machine learning. It unlocks new significant gains, but requires a modem and modern hardware to take advantage of this type of application. The challenges that customers face have changed. It's not just about finding the bad guys, it's about making our cities safer and smarter. We're looking at a wide array of new technology and new analytics that we intend to introduce in a continuous flow of software updates. As it goes beyond license plate reading, as mentioned earlier, vehicle type and color, we also have better GPS positioning, so on and so forth. We're also considering for future being able to identify different things, yet really to be determined at this point. In addition to the latest generation of the Atom CPU, we're adding the latest Movidius VPU from Intel. This chip is dedicated to enable our upcoming analytics for machine learning. Z3 is also a more future-proof solution. The Sharp Z3 base unit includes a few swappable module inserts. You'll be able to gain access to new functionalities without replacing the entire hardware. At launch, there are a few modules available. The PoE module, for instance, this supplements for video cameras for wheel imaging specifically. The navigation module, which is shown here. Other modules are being worked on as we speak, and we'll continue to further as we progress through the development. We'll let you know as they come out. Regarding the camera itself, it now comes with 3 lenses as opposed to the 2 lenses in the Sharp V and the Sharp X models. There's 2 monochrome sensors dedicated to LPR and 1 color video sensor. This offers a couple of substantial benefits. Being able to read license plates with different reflective properties, this is really good, especially as it relates to other plates, where the reflective coating may be worn off or even perhaps better chance of capturing paper plates. And also improving the license plate location and therefore the vehicle location. So why does that matter? In a parking enforcement context, accurately placing the vehicle on a map is essential as a different parking rule may apply. As you can see here from the graphic, where's the actual scanned plate? I mean, I read it, but I can't exactly tell where it was actually done at. By using the 2 LPR lenses, we're able to triangulate the exact position of the plate instead of doing an estimated offset. We'll also be able to find the vehicle parking orientation and accurately find its center. This combined with the advanced GPS swappable module, the Z3 will achieve an unmatched GPS accuracy. Here are a few specs on the Z3 camera. As this is a design training, I won't spend a lot more time on this equipment, but before we move on to the next topic, here's a quick comparison made out of an experimental unit for Z3. This here is, I'm sure some of you can attest to, this is a Sharp X context image taken from a parking vehicle. And this is out of the new Z3. As you can see, it says much more clear, and you can actually even read the plate in there. Please note this was done in California before all the confinement of the COVID issue. Server-side features. First up, LPR as a credential. When enrolling the Sharp V as an LPR as a credential, you don't need the AutoVu base as it is handled entirely from the Synergist platform and becomes a reader in the system, able to capture license plates as a credential for that particular user. As you can see from the graphic, the cloud link is required when enrolling the Sharp V camera, but this also shows one of the many use cases of the Sharp V as it shows the opening of the gate based on the valid user authentication. Free flow multi-tenant. Free flow multi-tenant allows for, among other things, automation. Use policy-based gate openings, for instance. If you're on the list, open the gate. If you're on a blacklist, block the gate from opening and trigger an alarm or any other event to action for that matter. You also have tenant management. Allocation of virtual spots to groups and entities, overcapacity notices, and reallocation at will for the tenant occupancy. With Freeflow Multi-Tenant, you also have transparency via recording. You can track time in and time out because it's recorded on the day-to-day stats. Also, not to mention security. Session-based tracking to check see if the same vehicle, license plate swap, vehicle damage, pictures of the video recorded for past investigations, for instance. This is how free flow can be architected within a general system. And this is for the inclusion of the free flow multi-tenant role. As you can see, the web-based role is there, and it can be visited by visiting the portal.autovu.com. Once you're there and logged in, this is the type of dashboard that you'll see today. And as time goes on, this dashboard is continually improved. One of our popular plugins, a stakeout plugin. Here's the idea of the stakeout plugin. Identifying a pattern on reoccurring license plates. It is not specific to a license plate or a list of license plates, but when a pattern is detected, different actions can be set up, and it can be done from several Sharp Vs as well. A little bit on the how it logically operates here. Based on the rule that you see here, the plate shows up 3 times within 2 hours. I want you to generate an alert. Using this plugin, the data can come from FlexReader or the Sharp V. Here you can see the plugin's actually installed, and you can check the identity and you can change the name of it. Here's the settings of the properties. In here you can see the Sharp V listed as the LPR unit from the properties of the plugin, and the settings related to the earlier slide of the 3 times within 2 hours, if you can see that. Outside of the standard on-prem, we'll be going over in a bit. Let's go over Genetec's cloud offering system within AutoVu. One of the two is going to be the AutoVu SaaS edition. As you see here, it is specifically for the fixed Sharp V deployments. There are no servers on-premise. The only thing that you'll need is the client applications, security desk. And if you're using the LPR as a credential, of course, you'll need the Cloud Link on-prem as well. You can subscribe to the service, pay monthly or yearly, and manage the systems without worrying about upgrades or maintenance. Everything is handled from Genetec side. Within the architecture, as you see here, everything is residing in the cloud outside of obviously the hardware that you need, the Sharp V cameras, and if you have any cloud links as well. You will need some ports open to talk to the SaaS, also from the IP network that the Security Center client apps that are on-premise need to talk to as well. So it's a very good distributed approach. The second offering is our AutoVu Managed Services. This is dedicated to the parking and law enforcement customers, really. It does include basically a base model of Security Center in the cloud. It's ideal for small cities, no server room, and only the security desk and the config tool are on-prem. You'll notice that access control is not part of this. A little bit more specifications on the managed services here. As you can see here, more specifically, the hit retention and the read retention. Hits are stored for a year, and the reads are stored for a month. And then you can have up to 5 client connections at any given time as well. A little bit between the two. As I said earlier, the SaaS edition is for fixed Sharp V cameras only. It's really for extending perimeter for distributed approach and using them as a license credential as well. The AutoVu Managed Services is for patrol and Sharp V. It's for the parking law enforcement opportunities and for free flow as well. Designing AutoVu. So with designing AutoVu, we have a couple of different architectures we can use. I'm gonna go over distributed architecture, which is a single directory. A lot of people are familiar with this as just being a single server, having everything on it, but you can also distribute this out to different server roles, either logically or physically. As you see here, I have a single directory located at a main site, and then all my servers are running different roles. Two things to note, really. Users from any location must log into the directory at the main site and be distributed out. But if that directory role ever goes offline on that last bullet point, the LPR managers and the archivers do continue to record locally at each site and will continue to record if disconnected from the directory. However, note that you will be unable to access that while the directory is down, because the directory is really what allows you for access to that. Our second way of doing things is centralized architecture or federation. The federation feature joins multiple independent Genetec security systems into a single virtual system. With this feature, Security Center users can view the control entities that belong to remote systems directly from their local Security Center system. Security Center can join or federate other security systems into a large federation of Genetec security systems. The system that joins others together is called a federation host. Security Center does this by creating specific federation role for each system that it needs to unify. The Security Center federation role connects to remote independent security systems to your local security center. That way, the remote system entities and events can be used in your local system. The Security Center federation role acts as a proxy between your local clients and the remote system that you need to connect to. One key factor I do want to mention is that in the new release Security Center, we have the ability to now allow for hits on the federated LPR entities. This allows departments to pull reads from other systems and not need to share the hot list, for which that is typically under NDA with that external system. On a large-scale deployment, the Security Center can federate thousands of independent remote systems. However, there are hardware and software limitations you must consider. Data is synchronized automatically. Our federation is not a single client app that connects to remote sites. It is a full-blown architecture that connects to remote systems, maintains connectivity, and synchronizes data between sites. Sharp storage. So as you see here, each Sharp camera has its own set of data packets that it can send back, and this is mainly due to the size of the imager. As you see here, the Sharp V will generate around a single 150 kilobyte packet. The Sharp X is about an 80 kilobyte packet, and the Z3 so far is producing a 175 packet. A few notes on these. Every time a hit is generated, it does produce a second record within the system. So for instance, if the Sharp V read as a single 150 kilobyte packet were to arrive and the server to match against it, the server would then generate a second 150 kilobyte packet for that hit record, because they are independently tracked. The picture data is kept separate from the LPR, and it is stored in the archiver role. So whenever you set up the LPR manager, you're gonna have to point it to an archiver to store those images. And about 20 kilobytes of each read and hit is going to be stored inside of the SQL database. This is the metadata that associated to that particular picture, such as the plate number, if they're approaching or leaving, the speed, and any of those analytics are going to be stored inside that 20 kilobyte packet. All right, design notes. So each LPR manager can logically hold up to 200 Sharp units. This is a logical limitation because of how we're splitting the data up. However, I do recommend keeping that number to about 100, and we'll go over that here soon as well. Hotlist and permits can be assigned either globally or via the LPR manager or per device. Keeping in mind that how you're setting this up with what camera does what, anything that is done within the LPR manager role is going to take precedence over whatever you have assigned inside of the single units. So if you have, for instance, everything assigned on the LPR manager role, but only specific lists assigned to the camera, all lists according to the LPR manager role will take precedence over the select view that you have. Whenever you're doing any type of failover situation, you need to make sure that any hotlists or permits reside on all the servers from within that failover situation. Because obviously, if you fail over to a machine, you need to have access to that hotlist in order to actually make a hit on it. Another word of note, the LPM protocol, which is a new protocol within the Sharp V, it actually stands for License Spec Management, for those of you who are curious. It uses the internal NIC of the server that the LPR manager is assigned. So with this said, if it is resolving to a class, class A or B or C, depending upon how it's actually set up, is where the camera is going to try to talk to it. So if you're on the LAN, talking to a 192 address is perfectly acceptable, but if you're out on a cloud somewhere, talking to a 192 address is not going to be appropriate. You need to a public-facing IP, which you need to set inside of the server in order for that to actually operate correctly. So keep that in mind. If enrolling the video as a Sharp V, you need to accommodate the storage for the 15 frames a second, H.264, and the 1.2 megapixel video for sizing. Also keep in note that the video from that camera does include 2 video feeds, the IR camera and that context camera. However, it does only eat up 1 camera license if you use it that way. I did want to go over a little bit about information. So information hubs is where you get a lot of the documentation that I'm pulling stuff from as well. GTAB being one of the more important ones that I use when designing stuff and getting installation videos or administration guides or product specifications, positioning guidelines, for instance. The resources.genetec.com is really where you find some of your blogs, your brochures, customer stories, white papers, so on and so forth. In fact, actually, this graph on the right-hand side here is actually pulled directly from GTAB for those who are interested. I do want to show this information. This kind of touches base a little bit with that 200 units per LPR manager role. As you notice here in the red highlighted areas here, the minimum server profile can hold up to about 50 LPR cameras. The recommended at about 100. And the high performance, we actually list up to 300 LPR units according to how it's actually set up. You'll notice there's a little 3 next to the right-hand side there. And if you look down further below, it's must be distributed between 3 LPR manager and archiver roles on this machine, kind of going back in hand with that 100 unit max. Also, the access control, if you're using that as a simple reader, you'll need to use the CloudLink, and CloudLink has limitations on the number of readers as well. I believe it's 256 if I'm not mistaken, but that can definitely be fact checked over at GTAP as well. So again, this is from the GTAP. This is just a simple spreadsheet that shows some of the matrix within the FlexReader and how we can accept those video feeds in and what we can actually process on each of these 3 servers that we have listed on the top here. One of the things I can say is don't hesitate to downscale. You don't need to have a 4K video running the LPR. You can have that same camera running at, for instance, 1080, or even as you see down up the top there is 960 by 540. Each of these StreamVault line computers is actually done and embedded against these particular applications here. So for instance, the SV300, if I'm running a 1080p camera at 30 frames a second, I can hold a maximum of 3 cameras. However, if I lower that down to 960 by 540 at 30 frames, I can hold up to 7, and 12 if I go down to 15 frames a second. And it really depends on the situation and the site, how fast the cars are going to be moving across the field of view. If they're stopping, for instance, if you can lower down that frame rate, for instance, on that. So I want to go a little bit about the networking within the Sharp V, and actually the Sharp X as well. But the Sharp V does now use the LPM protocol. NAT is supported, as I said earlier, but you must configure that within the router firewall. It has nowhere to go. And also you can verify in the connectivity within the Sharp OS portal. As you see here, is highlighted in red there, Security Center is connected at port 9001, and there are no video streams in this case. On the left-hand side there is a port diagram, and this again is inside of GTAP. You'll notice that the LPM protocol is using port 10,001 or 9001, depending upon the what you want to use there. and some of the older legacy ports, which is 8001, 8731, so on and so forth. And of course, if you want to access the portal, you'll need to have access to the HTTPS connection as well. So archiver relations with the LPR manager role. So we'll go over a little bit of the best practices within how to set this up. So if you have a single server with the LPR and video on the same server, as you see here, we have the Genetec server, we have the LPR manager role, and we have two archiver roles. Both the patrol and the SharpView unit are going to be enrolled into the LPR manager role, obviously, and then that picture data is going to be stored in the LPR images role, or the archiver role 1. You'll also notice that I have video units going to archiver 2. I have this separated out because in best practices is actually better to have the LPR manager have its own LPR manager archiver role assigned to it instead of having it share with the video. And this is due to data retention issues and stuff like that can crop up. When you have a multiple server LPR and video, as you see here, we actually have two. We have the directory role, which is handling everything, and then we have the LPR manager talking to its archiver, and then we have a separate server running video archiver, and they're just separated out in that manner. So a little bit of tips on performance. So you'll notice here that I have a couple of things selected. In this case, I actually have my set max length to 60 minutes per file, 100 megabytes. This is to help eliminate some of the headroom on the server and also delete the oldest files when the disks are full as well. That kind of helps out quite a bit as well. And this is in the advanced settings within the archiver, by the way. It is possible to achieve 99% plus reading accuracy with in a low speed environment such as a parking entrance. It is all about the good analysis of the environment and efficient positioning of the camera. You know, weather is always changing. Speeds, conditions, license plates, and a cardinal orientation will make each install unique. Those will all have an impact on performance of the system. Camera positioning will have a major impact on the overall performance of the installation. From one install to another, performance will vary. Our job is to limit those variations and ensure performance consistency. Number plates, tags, license plates are often different from one country to another. Reflective properties, as well as character heights, will have an impact on what hardware you select and how you should position the equipment. License plate with stacked characters will also have half the character height of a standard US plate. To maintain a similar level of performance, the LPR lens will need to be much more zoomed in, for instance. If you have extensive experience as a CCTV installer, that could play against you when deploying an LPR system because it's not about a good overview of the car. It's about maximizing the license plate transit time within the field of view of the LPR lens. Considering things like tailgating, obstruction, water reflections are now essential aspects of an LPR deployment. And speaking of water reflections, I got this interesting one from Europe. As you see here, it's upside down. And that was actually taken from this vehicle here. As you can see, it's actually correct, but it actually got the water reflection from the concrete below because obviously it was raining that day or somebody watered down the pavement, one of the two. The LPR camera saw it, it tried to read it, and that was the end of that. And by the time the other plate came through, it did eventually read it, but this is stuff that you have to kind of look out for when you're positioning the camera. As part of the tips and tricks, I wanted to go over a little bit about the how to get it to read fine. The LPR lens is about reading the number plates, right? So you want to maximize the viable license plate exposure within that field of view of the actual LPR camera and configure the OS to match the requirements. As you see here, I actually have a couple of different things. So license plate character height is between 20 and 100 pixels is kind of where you want to keep it. When you're getting the camera zoomed and focused, you want to stick about 35 pixels for a nominal plate read. Obviously, as you see here in the chart, license plate angle needs to be within 30 degrees tilt and within 50 degrees pan. And obviously, you need to make sure that you can see the license plate and that it travels throughout the field of view uninterrupted. Let's take an example. The sharp V is located on a gantry here with a small angle. First, we need to find the plate trajectory. Nice green arrow. Next, we need to find out when the license plate is still viable. An example, the characters are too large or too small to be identified. In this case, I have shown here with red lines. In the green is your viable license plate transit. Does it meet our previous requirements? The angle is okay, yes. There's no obstructions during the transit time. And I can see the license plate fully with nothing blocking it. So in this case, this is viable. Help us help you. Each read contains valuable information that will help you optimize the positioning. Character height, of course, exposure settings and gain, plate tilt. Please note this information is also shown in the camera's dashboard live view screen when the plate is actively being read. It's at the bottom. Let's see how we can improve this situation, because obviously this character height at 23 is pretty rough. Sharp OS offers analytics sections with several optimization settings. One of them, the plate tilt filter, as you see here. Indeed, as we know what the plate is, the angle of the license plate against the camera, we can set up a filter to avoid reading the on the side advertisement, for instance, on the parking entrance. We expect all plates to be within plus or minus 25 degrees maximum. This is then safe to restrict the filter to reflect this environment. Another is the character height filter. When the camera is close to 0 degrees tilt, the sharp V might read the license plate from far away, leading to poor reading as the LPR is too small. Again, for parking entrances, it's also likely the license plate will end up being very large in the LPR lens field of view. Setting this to a 40 pixels minimum height will ensure that the license plate will be read perfectly. In this case, you can see here I have the character height filter between 30 and 50 pixels to help eliminate those 10 pixels and 100 pixel reads. Here's the last slide for this section, and it is a relevant one. On the left-hand side, you can see an extract from the Sharp V admin guide. It basically explains different read strategies. A read strategy will affect the internal election process as we read and process 30 images a second. In each of those seconds, we can potentially read 30 times the same license plate. The process of election is to decide which one of those should be sent out. We want to read well and we want to avoid duplicates. The last read strategy released is the free flow one there at the bottom. It has a simple approach. Regardless of how many images the license plate is seen and processed, it will only generate when the vehicle is no longer visible. This gives the OCR algorithm potentially massive amounts of images in the most accurate decision and will yield the best possible results when dealing with that. The strategy most applies with gated entrances where the vehicles are going to be very slow or even stopped. Also, there is a note below that to note that because it does happen after the vehicle exits, there will be a latent read. And if you're using this to operate a gate, you'll definitely want to probably use the gate control because you'll get the read after the vehicle leaves. Site surveys. So, positioning the Sharp V camera is a couple of different things. First, you need to figure out what you need to do, what's needed from the client side. You need to locate an appropriate locations, locate a power source, make sure it makes sense, and then proper record keeping. Make sure that everything is atoned for. There are different scenarios to take into account. In this case, I show here garage parking, government and law, city corporations, but they all kind of intermingle when you're talking about what is needed. Garage and parking can be part of government law. It could be their parking lot, or it could be something that law enforcement is trying to capture for stolen vehicles, for instance. or within city corporations have garages as well, you know, if they have downtown garage parking, for instance. So there's a bunch of different aspects that you kind of have to keep in mind on what the client is wanting to use it for. Appropriate locations for the cameras. Camera placement has a major key role in the LPR design, making sure that the cameras are placed in a manner that captures the plate the instant that the end user is needing. Placement can be relaxed a bit if there's no objective to interact with, such as a gate, ground loop, kiosk. For instance, if opening a gate, moving the camera around 30 to 33 feet back from the driver's window to avoid car stacking. Purpose is if the LPR can't read the plate, for instance, having a second means of interaction is key. In this case, having a kiosk or having a Sepalia door station or something of that nature, so that should the LPR camera not be able to read the license plate, the user has a secondary method of opening that gate. Locating a power source. So locating a power source is needed, obviously, because you need to power the camera. You know, a couple of things to take into account. Are we going to be using solar, or is everything going to be wireless? Are we going to be doing 120 VAC for the network? Are we going to be using I said wireless, but network hardwire, fiber? You know, these type of situations we need to take into account when doing a site survey. Things to also keep in mind is location conflicts. Conflicts such as a sharp camera. It would be easier wise to read a plate at location A, but to install there require a bore underneath some concrete or concrete work and permits. Otherwise, mounting it at location B would have the same results, but it would be mounted to a telephone pole and pulling power from utilities. In this case, it's up to you guys to kind of make the choice to, along with the feedback from the end user, to figure out what's actually needed. And I'll say some key advice on this one. Doing a lot of site surveys, it's important to look beyond the scope. So if the end user wants to read at, we'll say, an intersection effectively, obviously having the cameras at the intersection is good. But it may be more applicable to have it mounted just outside of the intersection, a little further down the road. Maybe the road narrows down into a single funnel from 2 to 3 lanes to 1. So things like that to keep into account for tracking purposes and trying to figure out what the end user needs and wants, and make sure they actually get what they need. Camera positions can make or break the install. You have the tools needed to do a successful install. The field of view calculator is one of those great tools provided. If you've gone through training, you should have this tool. If not, you can reach out at the end of the slide. I'll give you some advice on who to actually contact. Let's go over how to get it going, keeping in mind that the settings can be saved, or you can do a screenshot and include it in the documentation. That's how I do my site surveys, at least. Okay, so in this first session here, as you see there that I've highlighted, make sure that you select the camera model that you're working with. In this case, it will be a Sharp B fixed. Don't worry about the zoom in this step unless you know offhand exactly what it is going to be. Making sure to also input the approximate speed of the vehicle that would be passing through this camera if it is unimpeded, so normal traffic flow, for instance, or if it's at a gate, how fast the vehicle will be going through if the gate was left open, for instance. On the second section here, as it relates to the physical positioning of the camera in relation to the lane that it is reading. Please note if you have trouble here, there are some graphics in the link next to the text. So to the left of the text box there, you have like the installation height and so on and so forth. If you click on those, it does give you a graphic of how that is defined. In this section, you'll find individual fields, keeping in mind that it'll update the top right graphic when you do this. The pan and tilt again, don't worry about changing this in the values at the moment unless you know the settings offhand. Next section here is my favorite. mainly because of the enable installation target. What this does is it will place a virtual dot wherever the install height is set to. So for instance, if you set it to 0, in this case, you can place a chalk mark on the ground at the coordinates listed below when it is enabled. When the installer of the camera sees that in the documentation, they can actually go through and do that, which is really nice, especially when you screenshot this. They would then be compliant to do whatever has been prescribed here specifically, instead of having to measure the actual tilt of the camera and all that. Once you have the camera pointed at that installation target, it's good to go from a pointing perspective. The move camera button is a strange one. Once enabled, you'll have control over the pan and the tilt of the camera using the arrow keys on the keyboard. When done, you'll need to click the button again to release the values to be edited. You'll also notice that on the right hand side of there is a camera mode commands. If you do hold shift while in this move command box, or the move camera box, it will increment the movement by 0.1 feet, versus if you don't do that, it will do it as a 1 foot increment. Up in the top right hand corner here that I have highlighted this graphic, this infographic displays an orange dot there below. This is the Sharp V's location in relation to the dashed lines representing the lane to be read. The two arched orange lines represent the minimum and maximum character height associated to this camera and what's set up in the plate characteristics field. The green dot, depending upon where you have it positioned, represents the field of view of the camera. Not the green dot, the green polygon. As you move the camera button, you can move this box around to get a better view. The objective is to get the green box green within the distances needed. You can mouse over the infographic to display the XY coordinates to make sure you satisfy the distance requirement. I was saying about the dot earlier, when you enable the installation target, it does plant a green dot on this infographic as well to represent where it's reading in relation to this camera. So on the bottom left here, we now have green boxes. They're very important. If they're red, that's bad. If they're green, they're good, obviously. Pay attention to these numbers and the green-red attribute. You'll want to balance these numbers in the left and right-hand boxes. This will ensure the same read rate on both sides of the lane, or the extreme left and the extreme right. Also, you want to err on the side of higher numbers while making sure that the car stacking will not become an issue. When you're in this area, please note that you can hold down the shift key, like I said earlier, to make it increments in 1/10. This goes for the zoom level as well. So if you notice on the command camera mode commands, you can use home and N to it says change the lens type. It's actually to change the zoom. And depending on the zoom level, this tool also shows you next to the camera selection, the first one there, next to the camera model that we have, to the right hand side of that, it'll actually let you know if you need to use a long range or a standard range camera in this case. So proper record keeping. So a couple of different things that you need to keep in mind when documenting stuff for your site survey or even during the install is going to be yellow stickers, passwords, and of course the survey documentation. In this case, whenever you first sign into the LPR camera, it's going to force you to change the password. And should you forget that password, there's definitely a way to retrieve it. As you can see there, I forgot my password, but it's quite involved. And also for the site survey itself, I go over pretty much everything that I just went over in the sense of all the attributes within the site survey to figure out, where the proper location is going to be, where I'm pulling power from, where I'm mounting the camera, where the network drops are going to be, so on and so forth. So I identify all those prior to actually doing the survey documentation, and that's where I plug it in there. This is an excerpt from one of my site surveys that I did a while back. As you see here, I actually have it drawn out. I don't expect you to go into this much detail. You can if you want to, if it's required of you, but This is just how I do mine. And as you know, I even have a note in there. This is due to there being delay from the loop arming, because on the bottom there with the 2 cameras, there actually is a loop and it's arming a gate and so on and so forth. So there's a couple of different variations that I denote inside of the site surveys. All right, let's go over server setup. Big tool specifically. So those of you who are not familiar with, this is the config tool. There are some additional stuff in here because I do have a demo license on the server, so I have video access control and LPR in this case. For our intents and purposes, we're going to be dealing with the LPR. So if you click on that guy and go into roles and units, this is what you're going to see. So as most of the other stuff within Security Center and within config tool, you'll notice that underneath my tab of LPR, I have a couple of different options as well. I have roles and units, hot lists, permits, permit restrictions, and so on and so forth. So all these entities do show up when you click on that icon originally, so you can always go back to this to verify and change any settings within there. I wanted to show this specific one. So under the LPR manager role, under roles and units, I'm going into resources. In here, I wanted to show this is where you have the setting for the archiver, so where the images are actually saved to. In this case, I just have LPR, so I just have one archiver. In some cases, I can call this LPR manager role 1 archiver, or however that is. And then, of course, all the encryptions and authentications and SQL Server stuff associated with that. As you can see here within the properties field, there are a couple of different options. In this case, right now, I'm under general settings. And here, this is where you actually define your retention policy for this particular LPR manager role. This is where you can actually go through and say, hey, I really only want 1 day of read data, but I want to keep my hits for a full year. And I don't really care about images for those hits, so I can make that 1 day as well. You can do all kinds of different iterations within this retention policy here. Next, we have live. So these are the legacy ports that are going to be utilized within Sharp V. So in this case, I'm using 8731, 5000, and then 8001 is going to be assigned per device itself. So this is the listening port that the server is actually listening on. This is where you actually modify it. And the same thing for the LPM protocol. This is where you define the port for that protocol specifically. So I want to go over a bit about the file association. So if you recall, I said that the presidents takes over for the LPR manager versus the role the entities. So this is where you would actually assign specific hot lists or permit lists to that particular LPR manager role, and every entity associated to it accordingly. And of course, matching. If you're using Sharp V specifically, any type of fixed camera, you'll need to enable matching if you intend to match against any hot lists. Otherwise, you'll just receive the reads. You'll also notice here there is a pass read matching. I won't go over it too much, but if you look down below that, it says search back in time a specific amount of time. Using an event to action, you can have this LPR manager role go back in time and search all the reads that were taken however long specified wise against any new hot list data that is available to the server. Another cool thing is the email notification. A couple of parts in this one that's very important. The very top field, the email attribute name, needs to be a field that is within the hot list if you wish for any emails to be sent based off of a hit from that hot list. And then you can associate email addresses either independently or as a group to be notified on that. And in this case, any emails sent will have the license plate image, the context image, the will image if there is any, and then all the information shown in that below text. Okay, so let's go a little bit over the AutoVu part numbers. So when you're quoting AutoVu fixed, a couple of things to keep in mind on this one. For standard offers, just the LPR, you'll need the AutoVu base package, any Sharp V kit specific to your area. You'll notice that I have AUKV WS850. For those who are interested, that stands for a sharp B, which is the third iteration there. WS stands for white standard. 850 stands for 850 nanometers, and then LC stands for it has the license plate and the context camera available in the housing. So with this, you'll need the GSE base 5.9. You'll need the GSE AV-S, which is the AutoVu base. And then, of course, you'll need the actual camera. You'll also notice that on the right-hand side there, I have AUKV generic LC. There is a generic part number for quoting purposes, as most of the, in fact, I think all the Sharp V cameras are the same price. You don't need to specify which particular one at the time, but you will need to before obviously ordering, because we need to know what to ship you. And then if you want the advantage, you have the advantages for the 1 year. And if you want to extend it, you have the extended warranties below that as well. On the left-hand side, on the bottom there, you also see the mounting brackets that are included with the camera. That arm mount is included along with that pole mount adapter that attaches to that arm, and some of the installation tools like the zoom and focus tools associated with that as well within that kit. You'll also notice that in the kit there is a 1 SHP connection. This is for connecting the LPR camera. So when you buy the camera, it does come with a connection license to Security Center. You don't have to buy that separately. So the LPR frequency counter plugin. This is that plugin that we were talking about with the stakeout. So in this case, you'll need the base of Genetec. You'll need the AutoVu base. You'll need a camera, obviously. And then the stakeout plugin is called AUPI frequency. So when you want to quote this plugin, this is that particular one. And then another one that we have that's new is the red light violation plugin. In that case, this plugin's name is GSE AV-S RLVD, red light violation plugin. When dealing with free flow, of course, you'll need all the bases and all that. But the GSE free flow base includes 1 lot, so keep that in mind. And then each additional lot, you'll need a GSE free flow 1 lot. So keep that in mind whenever you're defining how your free flow is going to be laid out. When doing LPR as a credential, you'll need the Synergist platform, obviously, because this is going towards the core. You'll need the camera and a cloud link. Optional, I would recommend doing the base of the AutoVu, mainly because you're getting an LPR camera. Might as well add the base of the LPR to utilize the LPR functionalities outside of just the standard Synergist, because otherwise it effectively becomes effectively a door reader that's reading license plates. Well, we went through this pretty quickly. It didn't take 2 hours as anticipated. I talked kind of fast. So if you have any questions, this is now the kind of time to ask. Howard, do we have any questions?
No questions yet, but we can stay on the line for a little while longer. And if anybody has any questions, please enter them in the questions box.
Do you have anything I should go over or touch on, Howard?
No, I think you pretty much covered it. Good job.
Thank you. While we're waiting on questions, I'll go over some other stuff. Let me get back to it. So again, some more information about the hub. In this case, resources.genetec.com is one of our new resource hub locations. In this case, you can search some of the data within that. We also have a YouTube channel within training and within Genetec. From here, you're able to actually go through and specific to LPR, you can see some of the speed testing that we've done, any of the installation help, and so on and so forth. Also, if you have any questions on any pre-sale support, you have the channel sales at Genetec, and you also have AutoVu SE.genetec.com. That's going to come out to me directly. along with the other SEs within AutoVu. And of course, you also have customer service. Anything support related, you can always go through GTAP. And this is some of the information. I'll leave this up here so you can copy down that information if you have any questions. I'll sit on this. And Howard, any questions yet?
Yes, Aaron, we have one. Does Z3 have plate tilt filter and or minimum plate size?
It does, yes. And if it doesn't, as I'm sure it does, it will be added soon because we're looking at migrating the product line from mobile to fixed eventually as well. That's the roadmap. And you folks are easy. I'm expecting some hard questions here. Come on.
No, nothing more yet.
Means we have some smart people on the line then. I like it.
Well, I'm not sure if you saw the comments, but we have a couple comments. Nicely done and great presentation.
Oh, well, thank you very much. All right, folks. Well, if there's any more questions, I'll end it at that. And of course, if there are some questions that crop up, as you can see there from the screen, AutoVuSE@genetec.com is an email address that I respond to. So by all means, ask away.